Hey everyone, welcome back to our final video on the Introductory to Science series for our class. This particular subject is how to convert units. The fancy word for that is dimensional analysis. So we're going to take a look at that and how it works to change one thing to another. So what you have is really two major systems of measurement that we're going to be using. Metric system you're probably less familiar with than the imperial system. If I said miles per hour, you'd probably have a better idea of how fast that was as a measurement of speed than if I said kilometers per hour. So with this, what you're able to do is you can turn one unit to another. That's going to become very, very useful in second semester when we deal with forces and F equals ma, Newton's second law. With that section, often the answers require that you're being in a unit called newtons, which requires kilograms, meters, and seconds. So you can actually get a problem where you're not in meters or you're not in seconds, and things end up needing conversions. One really famous example of this was when NASA was making a Mars orbiter. They're working with a company called Lockheed Martin, and the two weren't using the same units. So they're using different systems of units. One of them is using metric, the other's using imperial, and as a result, there were mistakes made, and those mistakes actually cost $125 million because people weren't using the right units and they're making miscommunications as a result. One warning with this particular subject is you want to pay attention to the system of how we do it. So make sure you're taking good notes on the math of this particular topic, because ultimately we're talking about a topic that uses fractions, and fractions are often weak for 8th grade students. The particular fractions that we're interested in are called conversion factors. They're going to take a unit and set it equal to another unit, and these equality statements are effectively going to create giant ones for us. You may be familiar with the concept of a giant one as something that you could multiply a fraction by. Like, say I want to turn 3/4 into 12ths. I might multiply by 3 over 3, and I'd have 9/12. That sort of manipulation of numbers is very common, and they call that 3 over 3 a giant one. Well, here we're actually dealing with giant ones that come because of the equality of two units. So a foot is 12 inches. So 1 foot divided by 12 inches is 1. Well, you could also write it as 12 inches over 1 foot. That's going to come into play later on when we're trying to ultimately cancel out from the numerator to the denominator. So what you have to do in a dimensional analysis problem is you have to look at the units you're given and effectively figure out how to walk them to the unit that you want. This is done usually by using a table of conversion factors. Now, there's several different paths that a person can take through a problem like this, depending upon what conversion factors they choose. Some paths might be faster than others. It really depends upon the list of conversion factors you're given. Do not panic about the conversion factors. There's so many of them that no one expects you to memorize these. In fact, for the most part, you're going to just set up the problems using the ones that you're given. Um, you're usually either allowed a note card or a conversion factor sheet on a test, or sometimes problems will just have them embedded directly in. So here we have a problem for conversion factors where we've been given that an inch is 2.54 centimeters, that's the blue conversion factor, and we have a foot is 12 inches, that's the yellow conversion factor. And notice that we're going to turn these conversion factors into fractions, and we're going to multiply them out in a way that causes the units to cancel except for feet, which is the desired unit in this problem. So the first place that we start with 140 centimeters, that cancels out on the next fraction. And you cancel numerator to denominator. And you see it again with inches. So inches in the blue cancels with inches in the yellow, and you're left with just feet. So let's walk through a problem here. We're going to try to convert half a mile into centimeters. And the first step you're going to do is you're going to write down the unit that you're given on the left-hand side. So in this case, I was given half a mile. I'm trying to turn that half a mile into centimeters. So I want to look up all the conversion factors that I possibly need to get from half a mile to centimeters. I'm going to need a length chart. If I look at the length chart here, I see that a mile is 1.61 kilometers. All right. Well, I also am going to need to get from kilometers to centimeters. So if I look down here at a metric prefix chart, I can go from kilometers, which is a 10 to the 3, down to centimeters, which is a 10 to the negative 2. So I'm moving from a 10 to the 3 to a 10 to the negative 2, which gives me a difference of 5. So there are 10 to the 5th centimeters and 1 kilometer. Now, I need to write these fractions as, for these conversion factors, as like 1 mile over 1.61 kilometers, or 1.61 kilometers over a mile. So there's two fractions that come out of every single conversion factor. They're called reciprocals. And I'm going to need one of these two in order to cancel out the units. So the way you figure out which one you need is that the right one will cancel the units, and the wrong one will end you up with some weird mess of units. So with 10 to the 5th centimeters is a kilometer, I again have two conversion factors. 10 to the 5th centimeters over a kilometer, and 1 kilometer over 10 to the 5th centimeters. So going back to my problem here, now that I have all my conversion factors, I have half a mile. I know I need to multiply it by something. So I'm going to multiply it by one of the conversion factors that will get rid of miles. So I'm looking at the kilometers over a mile or miles over a kilometer. Now when I look at those, I see that 1 mile over 1 kilometer would cause me to have miles squared over kilometers for units. While the other one, the 1.61 kilometers over a mile, well, that actually just give me, the miles would cancel out, and I'd have kilometers. So that's how I choose which one I'm going to use. One of them gives you weird units that make no sense, and the other one is going to give you return you something that you can use. So now the miles have canceled out, and I just have kilometers. Okay. So now I got to look again. I've got two different choices for kilometers to go to centimeters. One of them is going to result in something silly, and the other one's going to result in centimeters. So I'm going to multiply by the one that cancels the kilometers. It's 10 to the 5th centimeters over 1 kilometer. Kilometers cancels out. And now I can go to the next step, which is I need to multiply the numerators and the denominators. So I had 0.5 times 1.61 times 10 to the 5th in my numerator, and my denominator is just 1 times 1. Well, 1 times 1 is 1. And the rest of that stuff, according to my calculator, is 80,500 centimeters, or 8.05 times 10 to the fourth centimeters. Let's try another example here. So we got a problem with Tara. Tara's measuring out 345,000 milligrams of baking soda. And we want to know how many ounces of baking soda Tara has. The useful conversion factors for this one are that 16 ounces is a pound, 1 pound is 454 grams, and a gram is 1,000 milligrams. So if I start with what I'm given, 345,000 milligrams, I'm going to multiply that by one of these conversion factors. Now I need to go from milligrams to something, so I'm going to start with the milligrams to grams. And I line it up again so that the milligrams in the numerator, the milligrams up top, is going to cancel with the milligrams in the denominator or bottom of the next fraction. Milligrams go away, I'm left with grams. So now I need to use my pound equals 454 grams. I got two different reciprocals, so I need to line it up. I want grams on the bottom, so the grams cancel out. And now I'm in pounds. All right, well, in 1 pound, there's 16 ounces. I put pound on the bottom again, so that pounds cancel out. And now I have ounces. So I'm going to multiply, in this case, 345,000 times 1 times 1 times 16 over 1 times 1,000 times 454 times 1. Now, you don't need to write all these ones out when you're doing this on a real problem. I don't need to see that much work. You can just show 345,000 times 16. I'd be okay with that. And remember, you always have calculators, so just ask your calculator to solve these, because these numbers are really big. But they simplify down to just be 12.15859. Now, should I keep all these numbers? No, you're going to simplify that. You're going to simplify that down to 12.2 ounces. Don't write every single number, round to the nearest tenth or 100th, and you'll generally be right in my class. Now let's suppose you had an automobile tank that's holding 23 gallons. Okay, I got 23 gallons of gas, and the price for gas is 33.5 cents for every liter. So how many dollars would it cost me to fill up that car? Well, we know that a gallon is 4 quarts, a liter is 1.06 quarts, and there's 100 cents to a dollar. Okay, and gas is 33.5 cents for every liter. Those are my 4 conversion factors I'm going to use. I start with what I was known, which is that I need 23 gallons. I need 23 gallons of gas. So I go to my conversion factors that I found, and I see that there's a gallon to a quart. Now I could have 4 quarts over a gallon, or a gallon over 4 quarts. 4 quarts over a gallon is going to cancel correctly. So I'm going to cancel out my gallons. I'm in quarts. There's 1.06 quarts to a liter. I write it so the quarts is on the bottom. Quarts are canceled. Now I'm in liters. Well, I know that the price of gas for every liter is 33.5 cents. But I got to go to dollars. It's not good enough just to go to money. So I need to do one last conversion. That's 33.5 cents is going to be converted by $1 over 100 cents. And now the senses are gone, and I'm left with the unit I want, which in this case is dollars. You multiply the top, you multiply the bottom, and you end up simplifying out to $29.08. That's really it. That's unit conversions in a nutshell. We're going to be practicing these in class, and you're going to see these throughout the year, especially if you make a mistake on a lab and measure with the wrong instrument. You may end up needing to do some unit conversion. So that's really about it with this. Make sure you got the numbers and the math involved written down, and you didn't just write the stuff from the beginning. Otherwise, this video is not going to help you too much.